So in this video, we're going to explain the expected values and variances, minimum and maximum of the discrete random variables. Let's say we have this example here. Given this joint frequency table, where x takes on 1, 2, 3, 4, and y takes on 2 and 3. Let's first calculate the expected value of x. Question 1 says that find the expected value of x. You must sum for all x's, x multiplied by the probability of which that x value is taking on. Now, it means we're going to say for 1 multiplied by the total probability here, for 2 multiplied by probability here, you keep on adding all of those. So it's going to be 1 multiplied by, this is 0.32 plus 2 into 0.1, it's 0.15 plus 0.9, that's 0.24, plus 3 into, this is 0.26. Adding this 2 here, and then plus 4 into, adding this 2, you have 0.18, and the answer here should come out to be 2.3, and this is the expected value of x. As you can see, it lies somewhere around this region, because you can see that most of the data is lies in where x takes on 1. So the expected value lies around those ranges. If, let's say, we had bigger numbers this side, bigger probabilities this side, the expected value, which is the mean, will go towards that side. Okay, that's fine. Number 2 says find the expected value of y. We do the very same thing. Expected value of y equals to sum of all y's. Y multiplied by the probability of which that value of y is taking on. So the y takes on 2 and 3. And then you're going to add 2 and 3, sorry. And then we're going to take 2 multiplied by all these values added together. You get, let me just, you get 0.12 plus 0.15 plus 0.1 plus 0.08. That should be 0.45. And this one should be 0.55. It's just one minus the other one if you are in a hurry, but then yeah. We can confirm it. 0.2 plus 0.2 plus 0.09 plus 0.16 plus 0.1. That should be 0.55. Adding all of these ones together, and then you get your expected value to be 2.55. Expected value of y is 2.55. And then yeah. Then let's move to the next question. We have it calculate the expected value of a linear function that is 3x plus 2y minus 2. First simplify this and then plug in the expected value of x where possible, and where you must substitute it, and then substitute the expected value of y where you must substitute it. Let's simplify this. This can be written as 3 expected value of x plus 2 expected value of y minus expected value of a constant is just that constant itself. So expected value of minus 2 is just minus 2. And then we say 3 into expected value of x is 2.3. And then plus 2 into expected value of y is 2.55 minus 2. So this will give you, when you put it in a calculator, it must give you 10. 2 into 2.3 plus 3 into 2.3 plus 2 into 2.55, and then minus 2, you must get 10. And then you have question 4. You are done. This is the answer for this question. Expected value of this linear function is 10. Now, number 4 says you must calculate the expected value of 2xy. This can be written as, again, take the constant outside, 2 expected value of xy. And now you must now focus here. How do you get the expected value of 2xy? You say this is 2, and then remember they are not independent. They didn't say they are independent, so you cannot use that one. Now that they are not independent, we're going to say this is, you use the very same formula of the expected value of a discrete random variable, meaning expected value of this is going to be the sum of all x and y's for xy, taking on the probability of xy. Right? Now, this is going to be, keep the 2. Here, what you're going to do, let's go back to the table. It says xy. It says multiply x with y. Multiply 1, multiply 2, take this probability, plus 2 by 2, that's 4, multiply with this probability, plus 3 by 2, multiply with this probability, plus 4 by 2, multiply with this probability, plus 1 times 3, multiply by this probability, plus 2 by this, it's 6, multiply with this probability, plus 3 by 3, that's 9, multiply with this probability, plus this by this is 12, multiply with this probability. So that's what you're going to write here. Now let's do that. It's going to take a lot of space, so I'm just going to shift this equal sign into somewhere here so that we can start. So 2 times 1 is 2. We multiply that with 0.12, plus 2 times 2 is 4. 2 times 2 is 4. We multiply that with 0.15, plus 3 times 2, that's 6. We multiply that with 0.1, plus 4 times 2 is 8. You multiply that with 0.08, plus, I'm running out of space here, 1 times 3, that's 3, multiply that with 0.2, plus 2 by 3 is 6, multiply that with 0.09, plus 3 by 3, that's 9, you multiply that with 0.16, plus 4 by 3, that's 12, you multiply that with 0.1. And then after adding all of this together and multiply that by 2, put it in a calculator, it must give you 11.72. Let's just confirm it. It's 2 into 2 by 0.12 plus 4 into 0.15 plus 6 into 0.1 plus 8 into 0.08 plus 3 into 0.2 plus 6 into 0.09 plus 9 into 0.16 plus 12 into 0.1, and that all this multiplied by 2, it must be 11.72. And there we go. Now number 5 says calculate the variance of x. How do the values of x varies? Now let's check that. Number 5 says variance of x. Variance of x, the formula says you must take the expected value of the function x squared minus the expected value of x all squared. Now, let's calculate the expected value of x squared. What this means is we have x squared here, 1 squared multiplied by, you use the very same formula, but in the place of x, now you replace this x with the function x squared. Now here is going to be x squared multiplied by the probability of which that x is taking on. X squared here is 1 multiplied by this probability, plus x squared here is 4 multiplied by this probability. You do the very same thing for the rest of the x values. Now let's calculate this one now. It's going to be, like we see, for x equals to 1, is going to be 1 squared plus the probability that is 0.32 plus 2 squared, the probability that is 0.24 plus 3 squared multiplied by the probability that is 0.26 plus the x value 4 squared into probability of 0.18. All this one represents expected value of x squared. We are using the formula expected value of x squared is equals to sum of all x's. For all x's, the function x squared multiplied by the probability of x. Right? We're using this formula here. Yeah, it's fine. It's multiplication anyways, this bracket. Okay, now we must subtract expected value of x. And we calculated it here, that to be 2.3. Expected value of x calculated to be 2.3. We place it here with 2.3, but we must square that. After squaring that, after doing all this, you must get 1.21. When you plug it in a calculator, you must get 1.21. And then let's calculate now number 6. It says calculate the variance of 2 plus 2x. Calculate the variance of 2 plus 2x. Simplifying this is going to be, the variance of a constant is just 0. The variance, okay, here you have variance of a constant is 0 plus the variance of 2x. Now this is going to be written as, you must take this constant out, but when you take it out, you must remember to square it. Now let's square the constant 2 squared variance of x. And this one here, you just calculated it to be 1.21. Now this is 4, 2 squared is 4, multiplied by the variance is 1.21. And this will be, when you plug it in a calculator, it must give you 4.84. So this is the variance of this function, this linear function that they give you here. This will be the answer. And number 7 will be, it says if R is the minimum of x and y of this joint density, meaning now the joint density that they give you, find the probability that R is value 2, meaning find the probability that the 2 is the minimum. Find the probability where 2 is the minimum. Let's go to the joint density function and see where 2 is the minimum. Here 2 is the biggest, so 2 cannot be a minimum here. Here we have 2 and 2. 2 can be a minimum if we have a joint of 2 and 2. Here we have a joint of 2 and 3. 2 is the smallest, so 2 is the minimum again here. So we take this one plus this one. Here we have 3 and 2. 2 again here, it's there, and it's the minimum. It's the smallest number here. We take that. Here we have 4 and 2. And 2 is the smallest number in this probability. So we take this ones, and then let's see here. Here we have 3 and 3. 2 is not there. 4 and 3. 2 is not there. So you just take these ones and add all of them. You will get the probability that the minimum is 2. You get 0.09 plus 0.15, sorry, plus 0.10 plus 0.08. Adding all of this, you should get 0.42. And then it says again, for the same information, find the probability that R, meaning find the probability that the minimum is 1. Let's go again here and check where 1 is the minimum, where 1 is the smallest number in that probability. For this probability, we have 1 and 2. 1 is the smallest, 1 is the minimum. We take this one. Here we have 2 and 2. 1 is not there. So for the rest of these ones, 1 is not there because this one doesn't have 1. The white takes only on 2 and 3. So we forget about this ones. Let's focus on this value of 1 here. It will be the value that will give us where the minimum will be 1. Let's check there. For this one I just explained, we have 2 and 1 for this probability, that is 0.12. Here we have 3 and 1 for this probability, and 1 is the smallest there, and 1 is the minimum, meaning. So the probability where minimum is 1 is 0.12 plus 0.20. This will give you a 0.32. And that should be your answer for this. Let's do one example of maximum, and then we'll close this video. And then it says if, number 8, it says if S represents the maximum of x, y, of that joint density that they give you. So find the probability that that maximum is equals to the value 3. Meaning find the probability in the table where 3 is the maximum. Let's go and check. We have here 2 and 1. 3 is not there. 3 cannot be a maximum for this probability. Here we have 2 and 2. Here we have 3 and 2. And 3 is the biggest. Maximum, go for the biggest. 3 is the biggest number here. So we take this probability, that is probability of S being 3. Probability of maximum being 3 equals to 0.1 is the first one. Plus, let's check the other ones. Here we have 2 and 4. 2 and 4 for 0.08. 3 is not there. 3 cannot be a maximum there. Let's come here. Here we have 3 and 1. 3 is there, and 3 can be a maximum because 3 is the largest for 3 and 1. So we take that probability 0.20. Here we have 2 and 3. 2 and 3, the biggest number between 2 and 3 is 3. So 3 is the maximum there. We take plus 0.09. Plus, here 3 and 3. 3 and 3, remember for a value to be a maximum, all observations must be equal to that value or less than that value. Then that's when the value is the maximum. So here we have 3 and 3. So the maximum is equals to 3. They are both 3s, so we take again that value plus 0.16. So we took 0.1, 0.1, 0.16, 0.09, 0.2. So you see it's like you take all these ones down and to the right. It's like that pattern. For the minimums, for where one was minimum, we took only these ones. We would take, for if one was somewhere, if y was taking 2 on 1, 2, and 3, we would take again for these ones and the other ones of ones if they were there, but the y is not taking on 1, unfortunately. So we take only on this one. Check again when our r for this question that says our minimum should be 2. We took which ones? We took from here, because we had 2 as a minimum here, 2 as a minimum there, here again 2 as a minimum, here again 2. It's again that pattern. So for 2 as a minimum, this pattern. For 1 as a minimum here. For 3 as a maximum here. They will always form something like that. Now the answer here should be 0.55 when you put it in your calculator, and then you are done with this question. You will be fine. Thank you. Guys, don't forget to subscribe. Don't forget to subscribe, please. Support the channel.